In this final part of Chapter 5, we'll cover dealing with uneven cash flow streams, various formats for rates of return, and loan amortizations. We saw in Part A what an uneven cash flow stream looks like with the values placed on a timeline. We can solve uneven cash flow streams in several ways, using the basic formulas and solving more or less by hand, using the TI Business Analyst 2, using the TVM keys, or using the cash flow worksheet, or we can use Excel. We'll look at all of these methods. To find the present value of an uneven cash flow stream, you basically discount each cash flow appropriately and sum the discounted values. Note that the PV formula can be presented in two ways, with division and with multiplication involving a negative exponent. Taking the most fundamental approach, each cash flow is discounted back to time zero and summed. This can be done using either the formula, for example, for year 2, 300 divided by 1.04 squared is equal to 277.37, or using the TVM keys. N is equal to 2, IY is 4, payment is 0, future value is 300, compute present value. Either of those methods are a bit cumbersome. Fortunately, the TI BAII Plus has a built-in worksheet to handle cash flow streams, the CF worksheet. To access it, press CF. Now, since the CF worksheet has a variable number of entries, it's very important that it be cleared before starting a new computation. To clear the CF worksheet, press CF, second, and clear work down at the bottom. The display will show CF0 and zeros. Remember that for a value to be entered in a worksheet register, it must be keyed in and then enter pressed. Think of the worksheet like a column in Excel. To move to the next cell, you move down to the next register cell. In the TI Business Analyst 2, press the down arrow. The display will show CO1 for you to enter cash flow 1. Enter it and press the down arrow again. The display will show FO1 for you to enter the frequency of cash flow 1. If successive cash flows are the same amount, you do not have to, but you can, enter each one separately. You can use the frequency counter to tell the calculator how many cash flows are the same. The default value is 1. Continue entering cash flows and frequencies until all are entered. To find the NPV of the uneven cash flow stream, press NPV. The display shows I equal to 0, asking for the discount rate. Enter the rate and press Enter and down. The display will show NPV equals 0. Press Compute, and the computed NPV will be displayed. We're going to go through an example on the next slide, and there's a video tutorial that walks through the enter and down process. We'll be using this technique quite a bit, so it's important that you become comfortable with it. I strongly suggest that you get your calculator and walk through this example, step by step, to be sure you're comfortable with the enter and down process. Note that the minus $50 is entered by pressing 50 and then the plus or minus key. Be sure you arrive at the correct answer. The TI Business Analyst 2 Cash Flow Worksheet video tutorial posted with this lesson walks through an example as well, with a calculator simulator on the screen so you can follow the keystrokes. This is the video that covers using the CF worksheet step by step. It also covers how to find the future value of an uneven cash flow stream, a function not provided in the TI Business Analyst 2 student version. The tutorial is posted with this lesson, and I recommend that you watch it and work through the examples with your own calculator to be sure you're comfortable with using the cash flow worksheet, because we're going to be using it quite a bit in the coming lessons. Excel can also be used to solve for the present value of an uneven cash flow stream. One way would be to use the PV function individually for each cash flow and sum the results, much like using the TVM keys in the TI Business Analyst 2. Excel has a built-in NPV function that can be used as well. Note that the range in the Excel function begins with cash flow 1, not cash flow 0. We'll talk more about this in Chapter 11. For now, cash flow 0 in this stream is 0. Let's talk a bit about interest rates, how they're quoted and used in TVM calculations, and the impact of compounding period. The question here is, will the future value of a lump sum be larger or smaller if compounded more often, holding the stated interest rate constant? This is meant to address the power of compounding. The more frequently interest is compounded, the higher the future value. Interest rates can be classified in three ways. The first and most commonly seen is the nominal or quoted rate. A nominal rate is by law quoted as an APR or APY. An APR is the periodic rate times the number of periods per year. The quote must contain a percentage and a period, for example, 4% compounded quarterly. Because of the way it's quoted, an APR can be converted to a periodic rate easily. 4% quarterly is equal to 4% divided by 4 quarters, 1% a quarter. The periodic rate is exactly what the name implies, the rate charged per period, and it is the one we use in calculations. As we saw, 4% compounded quarterly equals 1% per quarter, so 1% is the periodic rate. Remember our caveat about N, IY, and payment having to match in terms of period? Well, if the periodic rate is 1% per quarter, then N must be the number of quarters, and if there's a payment, it must be quarterly. The third classification of rates is the effective annual rate. It converts a nominal or quoted rate to a rate that reflects annual compounding. With rare exception, an EAR is not used in calculations. Its main use is for comparisons. You're quoted one rate compounded monthly, another compounded daily. Convert both to EARs to compare them. A nominal rate can be converted to an EAR using the formula on the slide or using the Excel function shown. These effective rates demonstrate why it's important to convert APRs to effective rates for comparison. While the difference may be small, over time and with large amounts of money, that small difference can make a big difference. APR and EAR can be equal, but only if the APR is an annual rate, M is equal to 1. If the number of compounding periods per year is greater than 1, then the EAR is always greater than the APR. Nominal rates are quoted in contracts. They're not used in calculations or on timelines. Periodic rates are used in calculations and on timelines. Effective rates are used for comparisons. Remember again our earlier caveat about matching periods, rate, and payment periods. It's critical to arriving at the correct solution. This formula converts an APR to an effective rate, and this formula converts an effective EAR to an APR. Fortunately, your calculator has a worksheet called the I-Convert worksheet, which performs these calculations for you. This worksheet only has 3 entries, nominal, effective, and C/Y, compounding per year. You must enter compounding periods per year. You can either enter nominal or effective and compute for the other one. Excel has 2 functions which make these conversions as well, effect and nominal. Remember that in Excel, rates are entered as decimals. Note, anytime the compounding periods per year is greater than 1, the effective annual rate will be greater than the nominal rate. For this problem, we have a 3-year $100 annuity with a rate of 4% compounded semi-annually. The $100 is paid annually, but the rate is compounded semi-annually. You can't convert $100 a year to $50 every 6 months to make the payment and rate match. One way to solve the problem would be to manually calculate each future value and add them up. Remember, we'll be using the semi-annual rate, 2% per 6-month period, and N is the number of 6-month periods. The first 100 is compounded forward 4 6-month periods. The second 100 goes forward 2 6-month periods. A second method uses the EAR of the rate as an annual rate. 4% compounded semi-annually is 4.04% compounded annually. Now we can solve this as an ordinary future value of an annuity. Solving for the present value of the same annuity can be approached using either method, discounting each cash flow individually and summing the result, or using the EAR as an annual rate and solving like a standard present value of an ordinary annuity, or use the Excel present value function. Loan amortizations make use of TVM calculations to find the payment that will amortize a loan to 0 over a given period. The same principles apply to home and auto loans. Any loan designed to be repaid in equal periodic payments, reducing the principal to 0. Let's walk through a simple amortization example. We're borrowing $1,000 at 4% annual rate to be repaid over 3 years. Step 1 is to find the equal annual payment. We're solving for an annuity payment. The loan amount is the present value, and it's positive since it's an inflow to you, $1,000. Future value is 0 since the loan is to be paid completely down. N is 3 years, IY is 4%. Solve for payment, which will be negative since it's going to be an outflow from you. Step 2, interest paid in the first year is the loan balance, $1,000 times the interest rate, 1,000 times 4%, $40. Step 3, the reduction in principal in year 1 equals the total payment minus interest, $360.35 minus 40, $320.35. The year 1 ending balance is equal to the year 1 beginning balance minus the amount applied to principal. 1,000 minus 320.35 is equal to 679.65. The year 1 ending balance is equal to the year 2 beginning balance, and steps 2 through 4 are repeated. Loan amortizations are well suited to Excel, since once the first lines are set up, they can be copied down however many periods till the loan payoff. In this short example, we only have 3 years. If done correctly, the ending balance in the final year will be 0. Note that with each payment, the amount of interest declines and the amount applied to the outstanding principal increases. This ends our coverage of the time value of money. As mentioned in the beginning of this chapter, time value of money is one of the most fundamental concepts in finance. We'll be using these techniques throughout the rest of the course, so take time to review as needed to be sure you're comfortable with making the calculations. I strongly recommend that you view the posted tutorials. In addition, the Excel examples used in this lesson are posted with the lesson for closer review.